All right, here we go. So, we have some quadratics, right? So we're going to factor x squared minus 9 is x minus 3, x plus 3, right? All right, is equal to 0. So we get our critical values are 3 and negative 3. All right? So all of these were the same. Right? Now you just have to see if 0 works. If 0 works, it's an end statement. It's between the two. Right? Could we have just plugged in 0 and saw if it worked from the beginning? 0 squared minus 9 is greater than 0. Right? Is that a true statement? Negative 9 is greater than 0? That's false. Okay? So it's not between the two. It's an or statement outside the two. Okay? But we have to watch and make sure we use the ones that are not filled in because of this sign. All right? So this is number 2. All right, this one now you have to find them. You just can't plug in. Right, so we're going to do the rainbow here. This is multiply to be negative 8 and add up to be 7. So this is x plus 8. And this is x minus 1. Right, we're going to make it equal to 0. Okay, so then we have to divide by 4. Divide by 4. We have x plus 2 and 4x minus 1 is equal to 0. So our critical values are x equal to negative 2 and x is equal to positive 1 over 4. Okay, so that eliminates 2 and 3, right? Because they don't have the 1/4. Now if you put these on a number line, this is 1/4 here. And this is negative 2 here. 0 is between them, right? So that's the easiest one to put in. If you put in 0, you end up with 0 plus 0 minus 2 is less than or equal to 0. Is that a true statement? Right? You have negative 2 is less than 0 or equal to 0. All right? So that's an end statement. So you have negative 2 on the left, 1/4 on the right, and the same sign between them. So this is number 1. All right, a turning point of a parabola is, this is the x-coordinate, the opposite sign is 5. And the y-coordinate is the plus 3. You don't change the sign. So this is 1. Any questions on those 3? Beautiful. Moving right along. This one I said we have to isolate the absolute value first, so we divide both sides by 5. We have x minus 7 is equal to 6. Okay, now what's inside the absolute value sign can be a positive or a negative. It's the same thing. So we make x minus 7 is equal to positive 6. X minus 7 is equal to negative 6. We're making what's inside negative, not the other side. So we're going to add 7. This is x is equal to 13. We're going to add 7. And this is x is equal to 1. So this is choice number 4. All right. Now, which one fails to have a solution, right? So an absolute value of anything that's inside cannot equal a negative number. Okay, inside can be a negative, and then the sign would switch. But if I subtract 1 here, I'm going to get positive 16, right? And then I divide by 6, that's still a positive. This one here, if I subtract 7, this is 4, that's a positive number. This one here is minus 10, right? So you have 1/2 x plus 8 is equal to negative 5. Is that a negative? And then I multiply by 2. That's also negative 10, right? So this is the one that fails to have it. Now, number 4 is kind of a distractor. You see the negative sign there? Right, so if you subtract 4, right, you have negative absolute value of x is equal to negative 3. You say, well, that's a negative number also, Mr. Siegel. But we don't have the absolute value itself. We have to divide by negative 1 to get rid of that. So actually, the absolute value of x is equal to a positive. So this one is 3. All right? And this one's straight up. X, you don't have to do anything. Just make this equal to a positive. Make this equal to a negative 5. Subtract 2, subtract 2. So x is equal to 3. Right? I forgot the plus 2. X plus 2. Subtract 2, subtract 2. X is equal to negative 7. So all of them, so except for this one, right? So now if you put them on a number line, right, you have negative 7 and 3, zeros between them. So put in 0 up there. 0 plus 2, absolute value. Is that greater than or equal to 5? No, this is 2 greater than or equal to 5. That's a false statement. Okay, so it can't be an and statement, it has to be an or statement. Which one has the right symbols, right, the greater than or equal to, and is an or statement, is 4. X is less than or equal to negative 7 or greater than or equal to 3. All right, and then the old completing the square trick. Got to do it twice. X squared minus 12x. You take half of 12 and square it. What's that number? Plus 36. You also have to subtract 36. Right? Then you have plus y squared plus 4y. You do 4 divided by 2 squared is, this one was 36. This is what? 4, so we're going to add 4 and we're going to subtract 4. So all equal to 60. All right, now this trinomial factors, it's a perfect square trinomial. It factors like this: x minus half of 12, which is 6 squared. You still have minus 36. Y plus half of 4 is 2 squared. That's our basis of our circle equation, right? That's these three. This trinomial factors to that. And then we have minus 4 here. So what's negative 36 and negative 4? Negative 36 minus 4. Negative what, 40? We're going to move this over. Right, so this is our final equation of the circle. You know, you should do your evening prayers at night and complete the square before you go to bed every night. Yeah, just, you know, say a Hail Mary and then complete a square before you go to bed. I can't even say it with a straight face. All right, so the center is going to be what? Unlike the parabola and the absolute value, both signs change in a circle because it's really not a function. What's that? All right, that's that. And my radius is going to be equal to 100, the square root of 100, which is 10. All right, and finally, the last one is pretty straightforward also. Right, you don't have, I'm going to leave this here. Can we all have copy it down? We can go on? All right, we have 3 minutes. So we have 2x plus 7 is equal to 17. 2x plus 7 is equal to negative 17. Subtract 7, subtract 7. 2x is equal to 10, x is equal to 5, right? Subtract 7, subtract 7. 2x is equal to negative 24. Divide by 2, divide by 2. X is equal to negative 12. All right, so we're going to put those two numbers on a number line. Negative 12, 5. So we're going to check 0, because 0 is in the middle somewhere. So we're going to do x equal to 0. 2 times 0 plus 7. Is that greater than or equal to 17? This is 7. Greater than or equal to 17. That's false. So, and our circles are closed, right? Closed here, closed there. And they go this way. So that's an or statement. So in set builder notation, it's all the x's. X less than or equal to 12, negative 12, or x is greater than or equal to 5. Okay?